So here we have the chapter alcohols, phenols and ethers. So first of all, we will discuss about the important chemical reactions, some classifications and the important points that you have to remember for your NEET exams. So first we will move to the alcohols classifications. So we know that alcohols means they are the compounds which containing hydroxyl group, right? Hydroxyl group means it will be the OH group. So first we have to know how to classify the alcohols. So usually the alcohols can be classified based on the number of hydroxyl group and based on the carbon atom which contains the hydroxyl group. Okay, and so here first we have two classifications, that is sp3 hybridized carbon and sp2 hybridized carbon. If the hydroxyl group is connected to the sp3, we can again classify them into three. If it is bonded to sp2, we can again classify them into two. Okay, so here we have to know how what is the criteria for their classification, and we have to know how they are classifying them as well. Okay, so first we will consider the sp3 hybridized carbon atom containing hydroxyl group. So first we can classify them as primary, secondary and tertiary. So primary, secondary, tertiary means if the hydroxyl group connected carbon is connected to only one carbon and two hydrogen, that is called primary. Second one, the hydroxyl group connected carbon is connected to two alkyl groups or two carbons. And coming to tertiary, the hydroxyl group connected carbon is connected to three carbons. So this is the first classification. Okay, so in the NEET exams, we can expect the questions, that is, they will give the compound and they will ask like which among the following is a type of primary, or which among the following is a type of secondary. So those kind of questions you can expect. So we have to know the classification. Okay, so next one is the allylic alcohol. So allylic alcohol means here the sp3 hybridized carbon containing hydroxyl group will be there, and that is attached to the double bonded carbon. So this thing, see, the hydroxyl group connected carbon is here, and that carbon is connected to the double bonded carbon. So that is called allylic alcohols. Okay, now next is benzylic. Benzylic means there will be a benzene group, right? So the sp3 hybridized carbon containing hydroxyl group is connected to an aromatic ring. So this allylic and benzylic are different. Allylic means there is just, they have given that this is just double bonded carbon. But if you're coming to benzylic, it is like the hydroxyl group containing carbon is connected to the entire benzene ring. That is the difference. Okay. Now, the third one, the next classification is based on the hydroxyl group connected carbon is sp2. Again, we can classify them into vinylic and phenols. Phenol, as we all know, the hydroxyl group will be connected to the aromatic benzene ring directly. Okay, but this benzylic is different. Benzylic and phenols are different. Benzylic means the hydroxyl group is connected carbon. That carbon is the part of the benzene ring. But if you come to the phenols, the hydroxyl group itself is the part of the benzene ring. Means hydroxyl group will be connected to the carbon atom, and that carbon atom will be one carbon from the benzene ring itself. Okay, that is the difference between benzylic and phenols. Okay, now coming to the vinylic alcohols, here it is again, see, the hydroxyl group connected carbon is the double bonded carbon. So this is also different from allylic, and vinylic are also different. Allylic means the hydroxyl group connected carbon is connected to the double bonded carbon. Vinylic means the hydroxyl group itself is connected to the double bonded carbon. So that is the difference. So we have to know that difference as well, how they are classifying, how we are getting it, those kind of things we have to memorize. Means if there is any confusion, it will lose your marks. Okay, so don't do that. Okay, now we can move through the next one, preparation of alcohols. So we have different methods for the preparation. So we have to know the important preparation methods, because in the past papers we can see they might be asking regarding the mechanisms as well. There are questions. Okay, so here we have to know what is the exact product, what is the exact reagents that we are used for the preparation. Okay, so first one we are you preparing from alkenes. So if you are preparing the alcohols from the alkenes, which reagent you have to use? That is dilute sulfuric acid. Okay, and the product that you are getting here is a secondary alcohol. Okay, then coming to the mechanism we have to know, but that is not compulsory here, because here we have more products. We have to concentrate more on the reagents and the products that you are getting here. Okay, so if you consider this reaction, it will be here the carbon carbon double bond is there, and here the double bond is attacking the hydronium ion. Hydronium ion is usually producing from the acid, because this reaction is carrying out in presence of the acid. So the acid is reacting with water and they are producing the hydronium ion, right? So this hydronium ion will be attacked by the alkene, means the compound, and they will and they will produce the corresponding cation. And in the second step, the cation will be again attacked by the water molecule, and they will produce the corresponding the hydronium ion containing, or we can say it is the protonated one. And this protonated compound is undergoing deprotonation, means they are removing this hydrogen as H plus ion, and they are producing the final product. Okay, so this is the preparation from alkenes. Now, if you are considering the hydroboration oxidation reaction, so but the difference is the alkenes mean it is depending on the Markovnikov of addition, and hydroboration means it is depending on the anti-Markovnikov of addition. Okay, so these two names are also important here. Okay, now coming to the anti-Markovnikov addition or hydroboration. Here the reagent that we are used is B2H6. So diborane. Okay, so diborane react with the alkene, and see here we can see that here the compound produced is the alcohol itself. But what is actually happening here? This H3B, this is the side product of the reaction. So B2H6 means it is actually containing two BH3 units, right? So two BH3 units are there. So each hydrogen atoms will be replaced by the alkyl group from the alkene, and they will produce Br3 types. Okay, so this Br3 again react with the water and producing the corresponding alcohol. So this is the preparation through hydroboration oxidation reaction. Okay, now the next one from the carbonyl compound. So carbonyl compounds, we all know they are the compounds containing the carbonyl group. They are usually aldehydes and ketones. Aldehydes and ketones. Okay. So if you consider the aldehydes and ketones for the preparation of primary alcohol, we can see the aldehydes on reduction in presence of lithium aluminum hydride or sodium boron hydride, they will produce the corresponding primary alcohol. So we know that what is the primary alcohol means the hydroxyl group will be connected to the carbon, and that carbon will be connected to other three only one alkyl group, right? That is primary alcohol. And coming to the secondary alcohol, that can be produced from the ketones. So this is also important. If you want to produce a primary alcohol, you have to take the aldehyde. If you want to produce the secondary alcohol, you have to take the ketone. That is the difference. Okay, now the reduction of acids and esters, another method. If you have the carboxylic acid in presence of lithium aluminum hydride, that is the reduction reaction again happening here, and we are getting the product, that is the alcohol. Now not only the acids, we can use the esters as well. That is esters means it will be RCOO dash, right? So this esters can also produce the alcohol by using the same reagent. Okay, so this is another method. So here the thing that you have to remember is, if you want to produce a primary alcohol, use the aldehyde. If you want to produce a secondary alcohol, use the ketones. Okay, that is the difference. Now the next is from the Grignard reagents. So if you want to prepare the alcohol from the Grignard reagent, we have another method. Okay, so in order to react with the Grignard reagent, we need the carbonyl compound again. First, they will produce an intermediate or the transition state like structure. It is usually intermediate only, and they will finally convert into the alcohol. So this reaction mechanism is not that much important, but we have to know how the products are producing. So what is the reagent that you have taking, that we are taking here? These kind of things are very very important. Okay, so here if you are taking the aldehydes other than formaldehyde, the secondary alcohols will be obtained. See, if you are taking the formaldehyde here, the product obtaining is a primary alcohol. Now you are not taking the formaldehyde. Formaldehyde means it should contain only one carbon, right? So this is formaldehyde, HCHO. Okay. Now, if you are taking the other aldehyde, so that is CH3COH, secondary aldehyde, you will if you are taking the other aldehyde such as ethanaldehyde, propanaldehyde, or anything, or propanol or ethanol or anything, you will get a secondary alcohol. So from the formaldehyde, you will get primary. From other aldehydes, you will get a secondary. So this is also important. Okay. Now with ethylene oxide. So ethylene oxide means we know that is CH2, CH2O means it is a cyclic compound. Ethylene oxide is a cyclic compound. So if you want to prepare the alcohol from the cyclic ethylene oxide, we have to use the Grignard reagent. That is important. Grignard reagent is important. Okay, because in many of these methods we have used Grignard reagents, right? So Grignard reagent is the important reactant for all those preparations. So the Grignard reagent should react with the ethylene oxide and they will produce an intermediate. Then finally that intermediate on hydrolysis, they will produce the corresponding product of the reaction. So it should be an alcohol. That's it. Okay. So next one from alkyl halides. So we from ethylene oxide it is clear. So here this is please remember that this is an ethylene oxide. This is a compound of ethylene oxide type. Means it is a cyclic compound only. Okay. So from alkyl halide also we have the methods. So in alkyl halide we know the halogen atom is connected to the alkyl group, right? So from the alkyl halide we can react with the silver hydroxide, they will produce the primary alcohol. So the side product is silver halide only. See, in all these reactions, we have to memorize what is the reagent, what is the reaction condition, and what are the different kind of products. If you change any one of the reagent, you are getting a different product. Right. So that is very, very important because in the questions they would be asking like they will give the product. And they would be asking you to suggest the reagent for the reaction. So there will be confusing questions for the NEET exam. So don't be confused by seeing the questions. So whenever you are seeing the questions, you should get the proper answer. Means you have to memorize all the reagents for different reactions. That is the thing regarding the organic chemistry, especially for this alcohol chapter, aldehyde, carboxylic acid chapters. Okay. Now, coming to the alkyl halide reacting with potassium hydroxide. See, when they are reacting with silver hydroxide, you are getting a primary alcohol. This is what I told you before. When you change the reagent, the products are changing. So, if you take the tertiary alkyl halide, you are getting a tertiary alcohol. Got it? So, it is depending completely depending on the reagent that you are taken. See, if you are taking the primary alkyl halide, you are getting a primary alcohol. And here, if you are taking a secondary alkyl halide along with potassium hydroxide, you are getting a secondary alcohol. If you are taking a tertiary alkyl halide along with water, you are getting a tertiary alcohol. So this is also different. Now we are coming to the physical properties of the alcohols and phenols. Okay. So what I mean by the physical properties? Physical properties means it is majorly it is discussing about the boiling point, melting point, solubility, right? Or the density. These kind of properties are called physical properties. Okay. So what is the difference between the boiling point or melting point of different types of alcohols? We have three different kinds of alcohols. They are primary, secondary, tertiary. So how the boiling points are differing, how the solubility of these alcohols are differing from one to it means they differ from each other. Okay. So first discuss about the boiling point. So first thing we have to know The boiling point of the alcohols increases with number of carbon atoms. It is due to the increase in the van der Waals force. So this is one important point because we know that the van der Waals force is a kind of attraction, that is intermolecular force which is present in every molecules, right? And this is entirely depending on the number of electrons present as well. So if it is containing more number of electrons, the because this van der Waals interaction is arising due to the movement of the electrons only. So if they are containing more electrons, it will be having more interactions, and there will be strong interaction means the boiling and melting point. So during boiling or melting, what is happening actually, they are breaking the force of attraction between each others, right? So here we have to know that in case of these kind of compounds, during the boiling we have to break the forces. So in these kinds you can expect the questions like which among the following molecules are having highest boiling point. So we have to choose the option which is containing more number of carbon atoms. That is important. So each points are very important. Okay. Now among the isomeric alcohol, the boiling point is decreasing with branching. So first thing, when the number of carbon atom is increasing, their boiling point is increasing because the van der Waals force is increasing. Second thing, when the branching is increasing, that means the interconnections between the molecules are decreasing, right? As a result, the boiling point will decrease. So these two are the important things. Now we know the primary, secondary, tertiary. So this is the shortcut. Means in case of tertiary, we know that there are more branches. Means the carbon containing the hydroxyl group is connected to three alkyl groups, right? So in case of this tertiary, due to the branching, the boiling point will be less than that of secondary, and the primary will be having more boiling point because the branchings are less. Okay, so this is the another point. And one more means the important thing regarding the boiling points of these alcohols is the hydrogen bonding. We know what is a hydrogen bonding. Hydrogen bonding means it is the force of attraction between hydrogen and the highest electronegative atom, right? Like oxygen, fluorine, or nitrogen. So the alcohols usually they are containing the intermolecular hydrogen bonding. Means the hydrogen atom of the hydroxyl group will be interacting with either nitrogen, oxygen, or fluorine. So in the alcohols, we know that there is a hydroxyl group, means there is an oxygen atom, right? So there is a possibility for the formation of this intermolecular hydrogen bonding between the alcohol molecules. As a result, what will happen? This hydrogen bonding is the strongest one. So the breaking of this intermolecular hydrogen bonding means it is more difficult. So if there is a possibility for this hydrogen bonding, it will also makes the molecule with means they will we have to boil it more. We have to apply more temperature, we have to apply more heat energy to break these interactions. Okay. But in case of hydrocarbons, if you take the normal hydrocarbon, this intermolecular forces will be absent, right? Because there is no any hydroxyl group, it is only properly made up of carbon and hydrogen. But if you consider the alcohols, due to the presence of this hydrogen bonding, they will be having more boiling point than normal hydrocarbons. That is important. So alcohols and phenols are having higher boiling point than usual normal hydrocarbons due to the presence of this intermolecular hydrogen bonding. Okay, that is another thing. Next is the solubility. Solubility means it should be soluble in water, it should be mixing with water, right? So here in order to explain about the solubility, we have to explain on the basis of the hydrogen bonding only. If the because between the water molecules there are hydrogen bonds. Okay. So if the alcohols are capable of producing the hydrogen bonds with water, they will be more soluble because the solubility is due to the formation of the stronger bonds between the solute and solvent. If the solvent is water and if the solute is the alcohol, if the alcohols are producing stronger bond with water, we can obviously it will be more soluble in water. So we know that the alcohols are forming the hydrogen bonds. As a result, they will be producing more stronger bonds with water, so they will be highly soluble. Okay, so this is the another thing. Okay, and if you compare the solubility of other alcohols and phenols, the solubility of the phenols in water is much lower than that of the alcohols because of the larger hydrocarbon part. Because the alcohols will be containing alcohols mean it is ROH, right? Phenol means the hydroxyl group is directly connected to the benzene ring. So in case of the alcohols, due to the presence of this large hydrocarbon part, they will be less soluble. Okay, that is the thing. This is the thing regarding the solubility of the alcohols and phenols. Fine. Next, we will move to the formation of alcoholate ion. See, when the alcohols such as methanol, ethanol react with anhydrous calcium chloride or magnesium chloride, they will be producing the solid derivatives and they are called alcoholates. This is also important. Here also the reactions are also very important because they might be giving some incomplete reactions and we have to predict the product. Those kind of questions are also there, so beware of those kind of questions. So expect these kind of reagents and the products in your question paper because it might be there. So in order to predict the product, we have to know the proper reactant. Okay, that's it. Now we can see the chemical properties of alcohols and phenols. Reactions involving the cleavage of oxygen hydrogen bond or alcohols phenols as nucleophile means we have two bonds. Okay, two reactions. So this is important and this is also important. So the first one is the phenol. The protonated alcohol phenols are behaving as the electrophiles, and in the first one they are behaving as the nucleophiles. So both are different. Okay, so these are the two important reactions of this alcohols and phenols. So every reactions we can explain on the basis of this only. Okay, that is the thing regarding the important chemical reactions. Next, let's move to the questions from this chapter. So let's discuss the questions one by one. So we have the first question that is here. Which of the following alcohols react instantaneously with Lucas reagent? Okay, so here we have different options including primary, secondary, and tertiary. We have to choose the one which reacts instantaneously with Lucas reagent. Okay, so first thing we have to know what is Lucas reagent. Then only we can predict the product, right? So what do you mean by Lucas reagent? Lucas reagent means it is a mixture of anhydrous zinc chloride, anhydrous zinc chloride, and concentrated hydrochloric acid. Okay, so this is called Lucas reagent. Lucas reagent. So we have different kind of alcohols. First, we can classify them, right? So the first one is a primary alcohol because the hydroxyl group connected carbon is connected to only one carbon, and other two are hydrogens. Now coming to the second one, the hydroxyl group connected carbon is connected to three alkyl groups. So this is tertiary. Coming to the third one, it is again primary And coming to the fourth one, it is the secondary one. Why? The hydroxyl group connected carbon is connected to two alkyl groups. So primary, tertiary, primary, secondary. So among these three, we have to find out which one is more reacting, which one is reacting instantaneously with Lucas reagent. So usually the Lucas reagent means it is usually using it to used to classify the alcohols into primary, secondary, tertiary, because the Lucas reagent react in different ways with the different type of alcohols. Okay, here it will be substitution reaction. Lucas reagent is usually undergoing substitution reaction. That is, the hydroxyl group from the alcohol will be replaced by hydroxyl group will be replaced by the chlorine atom from the Lucas reagent. Okay, they will be replaced by the chlorine atom from the when the alcohols are reacting with Lucas reagent, the hydroxyl group of the alcohol will be replaced by the chlorine atom from Lucas reagent. And if you compare the reactions of different alcohols with Lucas reagent, we can say the tertiary alcohols usually react faster or instantaneously, and they will produce a cloudy solution. Okay. Next, if you consider the secondary, they will show turbidity, but not that much faster. So tertiary is most faster in their reaction. The secondary will react and they will produce the turbidity, but it will take some time. So the turbidity will be produced within a few minutes. Turbidity in few minutes. Okay, this is the thing. Now if you take the primary, it will be no reactions at room temperature. No reactions at room temperature. Okay, so this is the reaction. So if you consider the primary, secondary, tertiary, the tertiary will be reacting so faster. Secondary will react and form the turbidity, but it will take some minutes. But if you come into the case of primary, they will not react under room temperature. So here we have primary. The first one is a primary, second one is a tertiary, third one is again primary, fourth one is secondary. So among these four, the one which react more faster will be option B, because it is a tertiary alcohol. Coming to the next question, here we have two different reactions. It is given that the products A and B are obtained in the given reactions. So what are A and B? We have to identify the products A and B from the reaction. Okay, so first let us consider the reaction. That is, here we can see that The reactant used is an alcohol, and the alcohol is reacting with PCl3, phosphorus trichloride, and they are producing some alkyl halide along with some side product A. And another reaction is the same alcohol. It is not given whether it is primary, secondary, or tertiary. So the alcohol is again reacting with PCl5, that is the phosphorus pentachloride, and they are producing the alkyl chloride along with HCl and some other product B. So we have to know the complete reaction. Okay, first let us consider the first reaction. When 3 moles of the alcohol react with PCl3, phosphorus trichloride, they are producing 3 moles of alkyl halide. This is a preparation method for alkyl halide actually, but we are using the alcohols. Okay, and the other product means here what is remaining here in the alcohol we have three oxygen and three hydrogens remaining. Okay, and from PCl3 we have used three chlorines but one phosphorus is remaining. So that phosphorus and the remaining three oxygens and hydrogens combines together and they will produce H3PO3 phosphorus acid. That is actually A. Now coming to the second one, here also we can see there is an alcohol. They are reacting with PCl5 and they are producing the products RCl, HCl and B. So one is again alkyl halide plus HCl. So what is remaining here? See, from the alkyl halide, from the alcohol, oxygen and hydrogen is remaining, and from PCl5, phosphorus is remaining, and three chlorine atoms are remaining. Okay, so we can see that the hydrogen is always gone with HCl. So one of the chlorine is gone with HCl again. So we have remaining three chlorine, one oxygen, and one phosphorus. So the product will be POCl3, that is B. So the product A in the first reaction is phosphorus acid, that is H2PO3, H3PO3. So the product A will be H3PO3 and B will be POCl3. Okay, now let us see the options. The first option is H3PO4 and POCl3. That is not correct because H3PO4 is not producing here because it is H3PO3. So option B is correct, H3PO3 and POCl3. And others are also wrong because in other option it says saying that A is POCl3. That is not possible. Actually, POCl3 is producing in the second reaction. So the correct answer is B. Now, another equation we have here, that is the compound react with PBr3 and we are getting a major product A. That major product again heating with alcoholic potassium hydroxide and they are producing some other major product B. So we have to identify the products A and B from this reaction. Okay, so first let us start from the first reaction. That is here we can see that. So here the question is we have to identify the major product D at the end of the reaction. So there is a reaction sequence. The sequence is starting from methanol which is reacting with SOCl2 and producing some compound A And this A is reacting with potassium cyanide in presence of ethanol, reacting together to produce B. And B is reacting with sodium and ethanol. They are producing C. And the C is reacting with sodium nitrate and HCl. That is the reaction going on, and they are producing D. So we have to identify what is the major product D. In order to identify the major product D, we have to know what is the products forming in between. Means A, B, C, we have to know, right? So first let us start from the first one, that is methanol react with SOCl2, right? So we can write the overall reaction CH3OH, methanol react with SOCl2. They are producing here the hydroxyl group will be replaced by the chlorine and will produce the alkyl chloride, that is CH3Cl. Okay, now the CH3Cl is reacting with potassium cyanide in presence of ethanol. So in presence of ethanol, the reaction is like here the chlorine will be substituted by the CN group and they will produce CH3Cl, that is ethyl nitrile will be produced. And here we can say that A is CH3Cl and B is CH3Cl. Okay, now this B is reacting again with metallic sodium and in presence of ethanol. Okay, so the product will be here the CN group is there, right? So this will be producing the means the NH2 group will be introduced and produce CH3 CH2 NH2, means the product C is ethanamine, so C. Now the C is reacting. Now, the product C is undergoing the reaction with NaNO2 and HCl in presence of water as well. Okay, so the product obtained will be the alcohol. So the final product of the reaction is the alcohol containing same number of carbon atoms, that is CH3, CH2, OH. So this is D. So here we have got it as methanol, presence of SOCl2. They are producing CH3Cl on reaction with KCN. They will produce ethyl nitrile. Again, reacting with sodium, they are producing the product C, that is amine, and that amine react with NaNO2 and produce ethanol. So here we can say the final product D is ethanol. So from the options, A is incorrect because it is keto aldehyde. B is also not the correct answer, that is given as amide. And the third one is the correct answer, that is the ethanol. And the fourth one is not the major product, that is the chloroethane, that is not at all forming here. So C is correct. The next question, again, we have a sequence of reaction. We have to find out the final product D in the given reaction. So the major product D we have to identify, and we have a sequence of reaction. Okay, so here we are starting from ethanol, CH3CH2OH, and this ethanol is reacting with phosphorus and iodine, and they are converting into some product A, and this A is reacting with magnesium and dry ether and producing the product B, and this B is reacting with methanaldehyde and producing C. and C is undergoing a reaction with water and producing B. So first of all, we have to know the entire reaction. Then only we can find out what is the final product, right? So we can start from the starting reagent, that is ethanol. Ethanol, they are reacting with phosphorus and iodine. Here we will see that the hydroxyl group will be substituted by iodine and the product is CH3 CH2I. Okay, that is ethanol gets converted into iodoethane. Okay, now what is the so A is iodoethane. Now this A is reacting with magnesium in dry ether medium. So here we have the reagent magnesium in dry ether. Okay, so when this is reacting with magnesium, when an alkyl halide is reacting with magnesium, the product will be the Grignard reagent, right? Grignard reagent means they are having the formula RMgX. Okay, so RMgX means the alkyl group, magnesium, and halogen. So here the magnesium in the dry ether medium, the magnesium will be introduced between the alkyl group and the halogen, and they will produce CH3, CH2, MgI. So this is the product that you are getting here. Okay, so this is C, as this is B, and now we have to convert the B by the reaction with formaldehyde HCHO. So when this HCHO is reacting with this Grignard reagent, we have to know how they are reacting. So before that, I am considering the whole reactant like this. Then I can explain the mechanism. This is the HCHO, right? So how this Grignard reagent is reacting with formaldehyde. So in the Grignard reagent, we know this R group is having a negative charge. Magnesium is positive. It is a metal, and the halogen is negative. So here, what is happening? This negative charge is moving to the carbon. Okay. Now, because this carbon is having a partial positive and oxygen is having a partial negative, then automatically this bonded electrons will move to the oxygen. Okay, so you will get an intermediate here that will be the carbon connected to two hydrogens. And here we can see the group, that is the MgI group will be connected to the oxygen because the bond is breaking here, and it will be CH2 CH3 OMGI. So this is an intermediate actually. So this intermediate is C. So here the RMGX is breaking the bond like this, minus plus. Okay, so the alkyl group is having the negative charge. That's why they are attacking the positively charged carbon. Why it is positively charged carbon? Because carbon is having less electronegativity than oxygen, right? So during this bond breaking, this carbon will get a partial positive, oxygen will get a partial negative. That is because of the electronegativity of oxygen. That's it. Now coming to the product here, so this is the C. Now in order to convert to D, we are using water, right? So when they are reacting with water, the product will be like this OMGI bond with carbon that is breaking here, and this is hydrolysis, that is hydrogen will come here and oxygen or hydroxyl group will come here. So the product will be CH3 CH2 CH2OH plus this MgI is there, and they will produce MgOHI because hydrogen is going here. So this is the product. So the product D is propanol. Okay. So if you check the answer, we can see the correct answer will be propanol. That is N-propyl alcohol. Option A. Propanol means N-propyl alcohol only. Okay. So the product is N-propyl alcohol or propanol. Next question, we have to explain. Here also we have a reaction. In this reaction, it is given that the alkane that can be oxidized to the corresponding alcohol by KMnO4 as per the given equation. Okay, so here the alkyl groups on the carbon atoms are represented by R1, R2, and R3. So here we have to identify what are R1, R2, R3. Okay, so that is the question. So how can we identify R1, R2, R3? In order to identify this, we have to know the complete reactions. So here we know that KMnO4 is the given reagent, right? KMnO4 means potassium permanganate, which is a strong oxidizing agent. So when there is a strong oxidizing agent such as KMnO4, they will undergo, they will conduct the oxidation reaction, and that's why the addition of oxygen takes place or the removal of hydrogen will takes place. So here we are getting, anyway we are having the tertiary alcohol here, right? So it will be the alkyl groups. The R group is alkyl group and it is CH3 groups. So we can write the overall reaction, that is CH3, 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 hydrogen. Here we have, and the reagent is KMnO4. So here we can see the product is a tertiary alcohol. In order to produce a tertiary alcohol by oxidation, we have to take a tertiary, we have to take a nice, the tertiary alkyl only, means the carbon atom containing the hydroxyl group is connected to three alkyl groups. So it will be same here also. So we can say the R1 is CH3, R2 is again CH3, R3 is again CH3. If it is hydrogens, it will become some other, like tertiary, secondary, or primary. That is not possible here. So the R group is hydrogen, means the reaction is not possible. So in order to take place the given reaction, all the R groups should be the methyl groups. So the correct answer is option B. In this question, we have a reaction. It is an incomplete reaction. We have to identify the product P in the reaction. Okay, and the reactant is given as 3-methyl butane 2-ol reaction with hydrogen bromide. Okay, so we have to know what is the product obtaining here. In order to obtain the product, we have to know what is the complete reaction going on here. Okay, so let us consider the reaction first. The reaction is starting from the compound CH3, CH3, CH, OH, CH3. So the reactant is HBr, right? So during the reaction, we can see on oxygen atom we have one lone pair of electrons. So this lone pair of electron will take the hydrogen from HBr using the using the electrons only, and this electrons will move to the bromine and they will produce the protonated alcohol. Means the OH group is abstracting the H plus ion from HBr. So we will get CH3, CH, CH3, CH, here it become OH2 plus because it's already abstracted the hydrogen using their lone pair of electron. That's why it is a positive charge. Okay, so we will get CH3 plus the other one will other one will be Br minus. Now, this is a protonated alcohol now. So, in this protonated alcohol, this OH2 cannot stay here for a long time. So, they will be removing as a water molecule and they will produce minus H2O. They will produce CH3, CH3, CH, CH3. From here, the water molecule is eliminated. So, there will be a positive charge. Okay, now this is a carbocation, and this carbocation is a secondary carbocation. What is a secondary carbocation? Secondary carbocation means the positively charged carbon is connected to two other carbon atoms. So this is a secondary carbocation. Now this secondary carbocation will undergo a proton shift or hydrogen shift. Not proton shift, it is hydrogen shift only. Okay. So when they are undergoing hydrogen shift, what will happen here? The hydrogen from this methyl group connected carbon will move to the positively charged carbon and they will produce a more stable carbocation, CH2, CH3. So this is the positively charged carbon. So we know that if you compare the stability of carbocations, the tertiary will be more stable than secondary, which is more stable than primary, right? So here first we got a secondary, but there's a possibility in which the secondary can be converted into tertiary. So it will do that, and due to the hydrogen shift, they will produce the more stable tertiary carbocation. Now, this is the intermediate now, right? So still the product is, the final product is not yet produced. So this tertiary carbocation will be attacked by the Br minus, actually the Br minus is produced in the first step itself, right? So this carbocation will be attacked by that Br minus ion, and they will produce CH3, CH3, CH2, CH3. There is no change, and this carbon will contains the bromine. Okay, so this is the product that we are getting here. This is called 2-bromo 2-methyl butane. 2-bromo 2-methyl butane. So this is the final product. So now if you check the options, the first option says that this is some other product, not the correct one. Coming to the second option, this is the 2-bromo 2-methyl butane, that is the required product of the reaction. Third one is not at all possible because this is an alkene, and the fourth one is also not the product. The fourth one will be obtained when this secondary carbocation is undergoing the reaction with Br minus. But there is a possibility for the formation of more stable tertiary carbocation, right? So they will undergo the hydrogen shift and will produce the tertiary. That's why we are getting this product 2-bromo 2-methyl butane. Okay, so this is the reaction. So the correct answer will be always option B here. Next question is, here we have an incomplete reaction which is producing a mixture of products A and B. We have to identify both A and B here. Okay. So first, let us identify the reactant. This is an ether because alkoxy group is present. So we can write the overall reaction by considering the reactant. So the reactant is an ether having this aromatic ring CH2O, this benzene ring. They are reacting with hydrogen iodide in by heating. Okay, so here we can see that the product will be produced in such a way that here this bond between this carbon and oxygen will break, and this hydrogen iodide will be added. And this hydrogen iodide is produced by, they are producing H plus ions and I minus ion. So during the reaction, the hydrogen will go with this remaining part. So it will go here with this oxygen, and the I minus ion will attack the CH2. So we can see the product, that is CH2I plus the other product will be phenol. This is the reaction. So from the options, we can see that the exact product we can see in option D, that is the products of the reaction. Next question. Here we have different compounds. Which among the following will be most readily dehydrated under acidic conditions? So dehydrated means we have to remove the water molecule, right? So here we have different compounds. All of them are containing hydroxyl group. So which of them will be dehydrated more easily? That is the question. So dehydration means it is the removal of water molecule. Removal of water molecule is called dehydration. So we have to know that which among the following compound is producing the stable product by dehydration, they will be undergoing dehydration so easily. Okay, which among the following is producing the stable product by dehydration, that will be undergoing the dehydration. So anyway, the dehydration should produce the stable product. So that is the first thing. Stable product should be produced. Okay. So among these four, the one which can produce the stable product will be option C, because we can consider the reactant OH, CH2, COH, H. So when they are undergoing dehydration, we can see that one hydroxyl group and one hydrogen will be removed, right? So here we have two hydroxyl group. So the hydroxyl group from this one hydrogen from here, and similarly the hydroxyl group from here and one hydrogen from here will be removed, and they will produce CH2 double bond C H CH double bond CH. Here we have CS3 actually. Okay. So it will be CS3. This is not hydrogen, this is CS3. Okay. Okay. So this is the product that we are getting. Two hydroxyl group will be removed and hydrogen will be removed from the corresponding beta hydrogens. So you are getting a conjugated diene. Conjugated diene will be produced. Fine. So this is producing the conjugated diene. It means this is the product. This is the one which is undergoing the reaction readily. So option C is correct. The next question, we have two statements. We have to identify the correct option based on these two statements. Okay. So the first one, the acidic strength of the monosubstituted nitrophenol is higher than phenol because of the electron withdrawing nitro group. And the next one, orthonitrophenol, metanitrophenol, and paranitrophenol will have some acidic strength as they have one nitro group attached to the phenolic ring. So here first let us draw the structure of monosubstituted nitrophenol. That is, the phenol is still there, the hydroxyl group, and the nitro group is also there. Okay, and this is the monosubstituted phenol, and the usual phenol will be like the benzene group connected to the hydroxyl group. So the acidic strength of the monosubstituted nitrophenol is higher than phenol because electron withdrawing nitro group. Actually, this is a correct statement because the acidic property, we know that it is the ability to donate the H plus ions, right? As far as they are removing the H plus ions, we can say they will be more acidic in nature. So they should remove the H plus ions more fastly. So if you check the nitrophenol and the usual normal phenol, the nitrophenol will be more acidic. The reason, the nitro group or NO2 group is an electron withdrawing group. Electron withdrawing group. Okay, so due to the nature of this electron withdrawing, due to the electron withdrawing nature of this NO2 group, they will take all the electron densities of this ring, and it become easy for this hydroxyl group to leave the hydrogen as H plus ion. If you're coming to the phenol, there is no nitro group, so still phenol is acidic. Phenol can also remove the H plus ion, and they will produce the phenoxide ion or minus plus H plus. This is possible, but due to the absence of any of the electron withdrawing group, this will be in the normal rate. But in case of the monosubstituted nitrophenol, this will be the ability to remove ability for the removal of H plus ion will be more in this nitrophenol because of the presence of the electron withdrawing group. They will take the electron density and become easy for the compound to release the H plus ion. So the first statement is the correct one. Now coming to the second one, orthonitrophenol, metanitrophenol, paranitrophenol will have the same acidic strength as they have one nitro group attached to the phenolic ring. This is not correct because the one that I have given here is the orthonitrophenol, right? If you draw the structure of metanitrophenol, it will be as per the given. That is, the nitro group will be the third position of the hydroxyl group. This is meta. Now, if you coming to the the para nitro means the nitro group will be the opposite. Here is the hydroxyl group. Here is the nitro group, right? So this is the compound. So here we can see the orthonitro and paranitro. These two are different from that of meta. Okay, or meta and para are different from that of ortho as well, because this is the electron withdrawing. So in case of nitro group, we have seen that the nitro group is electron withdrawing group. That's why the removal of H plus is becoming so easier, right? But the position of this NO2 group is also depending the property, because this electron withdrawing group or the electron withdrawing effect or the minus R effect, the electron withdrawing effect can be called as minus R effect. Okay, so this minus R effect is increasing the acidic strength of orthonitrophenol and paranitrophenol. In case of metronitrophenol, See, in case of this orthonitrophenol, we have the electron withdrawing effect only, that is the minus I effect only. Okay, but if you come to the meta and para nitrophenol, other than this minus I effect that is there, plus minus R effect is also there. That is the resonance effect. So due to both these effects, the acidic property of these two will be usually greater than that of the, it means the metanitrophenol is only In the next question, it is given that anisole on cleavage with hydrogen iodide is giving which of the following product? First, let us consider the anisole. Anisole means we have a benzene ring that is connected to the OCH3 group. This is anisole, right? So they are reacting with hydrogen iodide. So what is the reaction? So usually this oxygen is containing two lone pairs of electrons, right? So in hydrogen iodide, we know hydrogen is del plus means partially positive and iodine is partially negative. So using the lone pair of electrons, the hydrogen will be attracted by this oxygen and this bonded electrons will move towards the iodine. As a result, you will get the product that is the benzene ring. Still here we can see the hydrogen will be bonded to this oxygen. So it is OH and this oxygen will get a positive charge because they are giving the electrons, right? And CH3 is there. And by the reaction with iodine, that is the remaining I minus ion is there, that is iodide ion, they will undergo SN2 reaction. SN2 means they will be undergoing substitution and they will produce the product that is the benzene will contain OH group, that is these bonded electrons will move on oxygen and the CH3 will go with the iodide ion and they will produce CH3I. This is the product. So you will get phenol and CH3I as the major products of the reaction. So here actually this I minus is taking the CH3 groups and these electrons are moving on the oxygen. So this positive charge will be removed. So if you come to the options, we can see option A is incorrect because in here we are getting iodoethane. Here if you are getting ethanol, so this is also incorrect. But 3 is the correct one. Phenol plus iodomethane. Phenol plus iodomethane. So these are the products. Now we have a reaction series. The equation is not given. We have to create it. Okay. The compound A on treatment with sodium is giving B, and with PCl5 they are giving C. And B and C react together to produce diethyl ether, and we have to find out A, B, and C. So A is on treatment with sodium is giving B, and B is reacting with PCl to give C. B and C reacting together to produce diethyl ether. So here A will be ethanol, that is C2H5OH, that is ethanol, right? Now this A is, it is given that on reaction with sodium they are producing B. So B will be sodium ethanoate because when ethanol is reacting with sodium metal, they will produce CH3, CH2, ONA, means the hydrogen will be removed by the sodium. Okay, so that is B. Now this A is reacting with, it is given here, A is on reaction with PCl5. They are producing some product C. So here when they are, this is an alcohol, when they react with the PCl5, the hydroxyl group will be removed by chlorine and they will produce C2H5Cl and that is C. And here it is given that B and C reacting together to produce diethyl ether. So what is B? Sodium ethanoate, right? So C, uh, CH3, CH2, not sodium ethanoate, it's, yeah, plus C2H5Cl. They undergo SN2 reaction and produce diethyl ether. Okay, so A is ethanol, B is the corresponding salt by sodium, C is chloroethane. So here, if you check the options, option C will be the correct one. Okay. So these are the important questions from the chapter alcohols, phenols, and ethers. If you have any doubt in between, you can ask me now. Otherwise, I'll wind up the session here. Okay, hope no doubts are there. Everything is fine. So this is the thing regarding the alcohols, phenols, and ethers. So these are the important questions that we can expect for your NEET exams as well. And these are the past paper questions. We already discussed the questions, recent questions, and the previous questions as well, like 2024 to 2013 we discussed. So if you have any doubt in between, you could have asked because no doubts were not there. So I think hope this is clear. So in the next class, we will meet with some other chapter, that is the coordination compounds. So we will discuss the same, like what are the important points of the chapter, and finally we will go to the past paper questions as well. So this is the thing. Okay. So that's all about it. So see you. Bye bye.